one more video for your stats journey this semester. It is on two population means. So we studied one population mean in the last unit, and we were able to do hypothesis testing with it. We were also, before that, even able to find a confidence interval for it when we're estimating what it is. I want to do hypothesis testing with the two population means today for your last lesson. Okay, so here's some important items to know. You might have to bear with me a little bit because I'm used to teaching this in a calculator. Okay, I will include the page in Google Classroom that will have this spelled out, how to do this in a graphing calculator, or with that paid version on your phone. If not, you're going to see me using this standard error right here and this test statistic. Ooh, don't get scared by that, all right? I don't think it's going to be too bad. So our answers might differ a little bit from the book, and I've kind of also looked at my CMO notes to see how I think they want us to tackle this. I think that we'll get through it. So you see pretty messy formulas there. And again, I'm just putting up the standard error right here just to show you that that is what we're dividing by in order to get my test statistics, my t-score is what I've been calling it. Okay. So degrees of freedom is going to be pretty nasty. We're just not even going to use that. Let's just say our degrees of freedom is going to be come from the smaller of the two samples. Yes. So whichever one's smaller, that's going to allow us a little bit more breathing room on that, and we don't have to worry with this formula. We just have to worry about that test statistic. That's the only one that we're going to need right now. Okay? So let's jump into our first example. So I'll show you this example, and we'll do the whole I show you one, you work the other, and we should be good. If you have other questions on it, we can definitely tackle it. But this one right here says a study is done by a community group in two neighboring colleges to determine which one graduates with more math classes. So the name of the first college is Hard Work U. It samples 11 graduates, okay, and their average is going to be 4 math classes with a standard deviation of 1.5 classes. We'll need all that information right there. Okay. The School of Hard Knocks samples only 9 graduates, and they find out that 3.5 math classes is their average, and then the standard deviation away from that average is 1 math class. There's a community group who believes that graduates from Hard Work University has taken more math classes on the average. So both populations are normally distributed, so we're going to be able to use my t-curve, or eventually my z-curve. I don't think we're going to get to a z-curve because my samples aren't big enough. But I want at the 1% significance level, I want to answer the following questions. Okay, so first up, and again, scroll back and forth between the slides if you need to. I've been reading over this problem, so I kind of halfway know what's going on. It first wants the null and alternative hypothesis. Okay, and so my null hypothesis, just from what we've been doing, I would go ahead. Remember, you want to have an equal to in there. So even if you just took the average from the School of Hard Work University, and then the School of Hard Knocks over here, I would assume that they're going to be equal. But since down here in my alternative, the community group is trying to show that Hard Work University graduates students that take more math classes than the School of Hard Knocks, I need a greater than here. Again, you could put a less than or equal to there, or you could put an equal to there. I'm not going to be picky on that, okay? So I would assume both of them are the same, but they're going ahead and covering themselves either way, okay? I'll tell you, whenever I worked it out, I actually put the equal to, okay? And so this is my null and alternative hypothesis. So they're kind of stepping me through this step by step on this one. What type of test is this? Let me leave that up here. So what type of test is this? This, let's see, I know it's going to follow this. And so I would assume that if I was to subtract these, go back to your test statistic. Remember, it has that subtraction in there. So if I take the Hard Work University and I take the, that looks more like an M, doesn't it? The School of Hard Knocks, I would assume that if I subtract them, I get 0. But I didn't. If I take my two means for my sample, I guess I should have used means up here. I actually got them to be, what was it, 4 minus 3.5? Golly, I think that was it. Yeah, 4 minus 3.5. And so I actually came out this way to 0.5. So where I'm landing at right there is actually going to be on a number line down here. You can think of it that way. And so this is going to turn out, in this case, to be a right tail test. A right tail test. P-value. Let's jump straight ahead to p-value. And this is where if you're using a graphing calculator or the app on your phone, you should be able to get to it a little bit quicker than what I'm about to show you. So you can either fast forward and go read that from the website that I posted, or we're just going to go old school on this. We're just going to use our table, which I have pulled up here in a minute. I'll show you. And we're going to go ahead and calculate our own test statistic. So my test statistic, as you can see, right off the bat, it said that it wanted, let's see, let me go back to it real quick. Right off the bat, it says that it wants x bar, x1 bar minus x2 bar. Okay. And so again, you might want to copy this down. I wish I could just like copy that out and paste it. I guess I could write it down. That might help. So let's just say x1 bar minus x2 bar minus mu1 minus mu2. That's what I would expect it to be if I subtracted them. I'm gonna call that 1 or 0 here in a minute. I have s1 squared over n1 plus s2 squared over n2 take a square root of all that. So let's go back and make sense of this. What is the p-value? So the p-value is going to be, well, what did I get whenever I did subtract them? Whenever I did subtract them, I got the difference between them to be half. Minus my mu, this, a lot of times I believe that's going to be 0 for us right there. Okay? And we're going to have to calculate our standard error by hand. Okay? There is, again, a way to do it in graphing calculator, go for it. It's not going to be too bad to do it by hand. What I'm going to do is I'm going to take what they gave me for the standard deviation of, let's see, which one is this? Is this Hard Work U, the S1? And it was 1.5 squared over the number of people that I sampled. And I take my standard deviation for School of Hard Knocks over how many people I sampled. And so whenever I did this song and dance in my calculator, I got this number, okay? And we're using a t-score on this, so we know that we need 2 pieces of information. We need to know what the t-score is, and we need to know what the degrees of freedom are going to be, okay? So for my degrees of freedom, what I'm going to do is I'm going to take my smaller of my 2 samples. And remember this year, Jillian didn't get to choose which player she wanted from the stack of people in the cards. She ended up with some guy named Roger Federer. And so everyone got to choose their player except for Jillian. So there was one person here that didn't get to choose, and then everybody else did. So in this case, it would be 8 people for my degrees of freedom. Okay. So we have 8 degrees of freedom, a t-score of, well, it's pretty much, what, 0.89? And so let me see if I can get out of this real quick. Let's see. So degrees of freedom, is 8.8. Oh boy, is that it right there? 0.889? It's not what I got on mine. That's it, 0.8899. So yeah, it's super close to 20% for the area that is over here in the right tail. Okay, so let me go back to my, so what is my p-value? My p-value is going to be close to 20%. So I'm using a calculator, and if I use the correct degrees of freedom, it was like at 19 point something percent. So I feel pretty good with that. I don't think you're going to have anything that's going to be that close to your alpha level. Okay, but my conclusion, what is my conclusion on this? Well, my conclusion is going to be to not reject H naught. Okay, I can't reject H naught. Okay, I did not get something that was so far over in the tail of this curve that it was unusual. Less than 1% being unusual this time. Okay, I got 20%. That's kind of close to the middle. Okay, so do not reject H naught, and then I can finish it up with my sentence. There is insufficient evidence to conclude that the average number of math classes taken at, getting those, yeah, we did Hard Work University, right? Hard Work U, that says Hard Work. Hard Work U is greater than I'll just say that the School of Hard Knocks. Okay. Notice that I again started it off the same and said there is insufficient or sufficient evidence to conclude that, and then all of this down here is just my alternative hypothesis. So I'm still using that same rubric coming down and going through, and I wouldn't be surprised if it's going to be written out like this on the final. Last year, I know on the final, it was a multiple choice, and you had to find the correct one going down the list on the multiple choice. Okay? All right, we are almost there, guys. We are almost there. So I'm going to let you guys do this one. There's a little bit more detail on this. Okay, and so on this one, it doesn't tell you what the average is or the standard deviation. You've got to go into your graphing calculator and find it yourself. Okay, so it looks like you're going to have a mu for your online classes, and you'll have a standard deviation for your online classes, and you'll have one, I'm going to call it my mu for face-to-face classes, and a standard deviation. Face-to-face. So you either need to do that by hand, or you need to just put those in the graphing calculator to figure out what they come out to be. Okay, and those should work on the free edition. Okay, so you can, or you can do it by hand, whichever one suits you best. Go ahead and fill that in. Answer the questions on this next slide right here. And again, it's just asking for p-value, but the way we're doing it this year, we're having to do it with the test statistic. And so I would know how to do that. But fill this in, fill in your stuff from the last slide, and then we'll come back and see if we match. So go ahead and hit pause on the video. Let me get on the right slide. There we go. That might be the longest example I had you guys do on your own. Okay. Now, this is all based off of the fact that I hope I put in all the data correctly from the chart. Okay, so whenever I put in my data for my online, I got what was in the box, and whenever I put in my data for face-to-face, I got what was in the box. Okay. Again, I would assume that these would be equal right here, but so I think that putting an equal sign right there is the best way to go. We didn't end up with a left-tailed test, and we were so far over on my chart with this negative 3 point, well, it was actually a positive, doesn't matter if it's negative or positive, 3.23 at 29 degrees of freedom, that I was way less than even 1%. And so I get to reject H naught and have my conclusion. Now, notice on this one, if you remember, I used the 5% level of significance because they did not tell me a level of significance. So anytime they don't tell me, I want to use that 5% right there. That is kind of the norm to use on a lot of these. Okay. Hope that went well. If there's questions on there, put a big star by it. We can work it out during our Q&A. I'm going to skip example 3 for now. If you need more examples on this, let me know. I'll come back up here and make some videos. But I got these 2 problems for you to kind of work out on your own. Check your answer. Again, they're probably using a little bit different formula than what we're doing as far as degrees of freedom go. And if we're using a chart versus a calculator, that's going to give you a little bit of wiggle room as well from what the book has. The big thing I want you to see is whether or not you are rejecting or do not rejecting H naught and getting the correct p-value on these. Okay, so good luck, and I will talk to you guys soon.